Okay guys, we are going to talk about reflex today and what happens in a reflex and what all the structures are involved in those actions. Alright, so let's say we have a foot and a Lego. Alright, the foot is coming down into the Lego and it steps on the Lego. What happens? Well, we have a stimulus from the Lego creating pain going up into the leg all the way to the nervous system. The central nervous system. So we have receptors here in the foot and basically every part of your body. We have pain receptors that are at the ends of the nerves to catch that stimulus. So when we stepped on that Lego, it sent a stimulus, a pain receptor stimulus, all the way from our foot to our legs, all the way into our spinal cord, into the brain, and then the brain is sent another signal down into our bodies to counteract or to basically do a reflex motion. So when we talk about a reflex, we have different muscles that aid us in reflexes. So you have flexor muscles and extensor muscles. Usually flexor muscles are going to be doing an inside motion. So you're going to bring it to flex. You know, you're buff, you want to flex. And extensor muscles, you're going to extend. So basically it's in the name, you're going to flex or you're going to extend, okay? In this movement here, in this example, you step on the Lego, with your foot, and then you have a response from your brain. So if you could look at me, I step on the Lego, alright? I step on the Lego, and I bring my leg up. So I'm flexing with this leg because I have a signal sending to flex this leg, and then I am extending this leg. So right here I am having an ipsilateral movement, and then here a contralateral movement because I'm trying to balance myself. Put more support in this leg and flex this leg to bring it back from that pain. So ipsilateral, contralateral. Now we're going to look at the different structures that are involved in these reflexes. Alright guys, so we talked about reflex and contraction, and which is also called antagonistic contraction when you have that flexion because of the shortening of the muscle. And then we're going to talk about the nerves it goes up and how it does that. So you have pseudounipolar neurons, which basically have two actions, one going to the central nervous system, one going to the muscles. Okay? And then here we move into the spinal cord. This is the actual spinal cord, if you had to cut in half. Here goes the pseudounipolar neurons into the dorsal root ganglia. So that's how it's going to go inside here in the dorsal root ganglia. And then a little helper called the interneuron, which are neurons in between other neurons or axons, are going to be processing that information. And at the same time, it's going to send it all the way into the central nervous system to get processed, that action, the stimulus, to send it down into the motor neurons. Okay, the motor neurons are the actual things that are going to make the response, or the stimulus, or the reflection, or the reflex. And it's going to send it through the ventral. So we talked about the pain receptors, and we talked about the nerves that go all the way into the cell and how they do all these. But this is what an actual nerve cell looks like. So this is the nerve cell. Here's the dendrites, which receive the information, and you have the axon, which is the ones that send the information, the neurotransmitters, into the synapse here, and they attach into the other synapses or the other dendrites. And if you move here, you can see here we have a polysynaptic axon. So in a nerve cell, this is the axon. This is where the neurotransmitter are going to go down. And you basically have more, but you have two different types of synapses. You have excitatory and inhibitory. So in the excitatory, you have the neurotransmitters that are going to come down here into the connection into the synapse, and it's going to send the neurotransmitter down, which are most likely to have a reaction. So it's probably going to do an action potential, and you're going to send a signal. And then on the other side here we have, in the blue, inhibitory neurotransmitters. So it's going to send them down, and it's probably not going to send a signal. So when you have more excitatory than inhibitory, you're going to probably have to send a signal. So we talked about the action and how the stimulus goes into your body and transfers down into your vertebrae and everything. But now we're going to talk about reverberation, which is basically a stimulus that's coming down, but it's also looping back into the system. So you have that positive feedback, and which helps with different allocations in the body. So it's going to come back up, and that's reverberation. It's going to echo, and it's going to do it again. Thank you very much, and this is my project. Hope you like it.